This is lesson 94 in Saxon's Algebra 1 3rd edition, and this lesson is a continuation, sort of lesson 92. It is distance, motion, rate, those kinds of things. So this is uniform motion of the form d1 plus d2 is equal to n. Now, before the problems that we had one distance and it was equal to the second distance. The problems we're going to be working with today in this lesson are we have a distance to one place plus a distance to another place is equal to a number. All right, so let's look at examples of that and then we'll work our practice problems. First example, a southbound bus left Fort Walton Beach at 9 a.m. 2 hours later, a northbound bus left the same station. If the buses traveled at the same rate and were 352 kilometers apart at 2 p.m., find the rate of the buses. All right, this problem is going to take a little bit more digging on your part to pull out the numbers that you need. All right, so the first thing we know is that the distance of the northbound bus and the distance of the southbound bus is equal to 352 because they were that far apart. And we know that the rate of the northbound times the time of the northbound equals distance, and rate of southbound plus times time of the southbound equals the distance of the southbound. So this distance plus this distance is equal to 352. Now, what are the independents that we can pull out? All right, we know that the time of the northbound, we have to kind of figure that out. The southbound left at 9 a.m. and from 9 a.m. to 2 p.m. is our time. And from 9 a.m. to 2 p.m. is a total of 5 hours. We know that that was the southbound bus. The northbound bus left 2 hours later. So he didn't leave until 11 a.m. So 11 a.m. to 2 p.m. is 3 hours. All right? Now what do we know about the rate? The same rate. So the rate of the northbound is equal to the rate of the southbound. It is asking us to find the rate, not the distance, the rate of both buses. When you find one, you found the other because they're equal. All right, so we're going to plug in these things that we've pulled out into this equation, substitute them in. We know that 3 times Rn plus 5 times Rn is equal to 352. When we add our like terms, we get 8 Rn is equal to 352. And then if we divide by 8 on both sides, we find that the rate of the northbound bus was 44 kilometers per hour, and if that was the rate of the northbound, it's also the rate of the southbound. In example 2, a train starts from Toledo at 11 a.m. and heads for Mackinac, which is 332 kilometers away, at the same time. All right, so they're going to have the same time. A train leaves Mackinac and heads for Toledo at 65 kilometers per hour. Now in this one, we know the rate of the second train. So we have the first train and the second train, and together their distance is 332 kilometers. If the trains meet at 1 p.m., what is the rate of the first train? All right, we know that the time of the first train and the time of the second train is 2 hours because it says 11 a.m. to 1 p.m. That's their time of travel. We also know that the rate of the second train is 65 kilometers per hour. So we know three things that we can then substitute into our equation. So R1 times 2, the time, plus 65, which is the rate of the second, times 2, is equal to 332. When I do all my multiplication, I see that 2RI plus 130 equals 332. I subtract 130 from both sides, and I find that 2RI equals 202. Divide both sides by 2, and I find that the rate of the first train, which is what I'm looking for, is 101 kilometers per hour, or kph. Okay, do another. The ships were 400 miles apart at midnight. That 400 miles is the distance, okay? They were headed directly toward each other. If they collided at 8 a.m., so our time is what? They left at midnight and they traveled until 8 a.m. So their time, the time of both of these ships is 8. The time of the first ship, the time of the second ship are both 8. Find the speed or rate of both ships if one was 20 miles per hour faster than the other. So let's say that the rate of the first and the rate of the second are not the same. If I added 20 to the second one, it would be the same as the first. Alright, so now the rate of the first then must be, we're going to solve for that. So rate of the second plus 20, that's this that we're substituting in right here, times 8, which is the time, plus 8 times RS equals 400. We've got 8RS plus 160 plus 8RS equals 400. Add our like terms. 16RS plus 160 equals 400. Subtract 160 from both sides, and I have 16RS is equal to 240. When I divide both sides by 16, I find that RS is 15. So I'm going to put that into this equation. RF equals RS plus 20. So if RS is 15, then 15 plus 20 is 35. So the rate of the first one is 35. Okay? The rate of the second one is 15. Now I have found the speed of both ships. Okay, let's do your practice problems. An eastbound bus left Ukiah at noon. 2 hours later, a westbound bus left the same station. If the buses traveled at the same rate, okay, so the rates are the same, and were 500 kilometers apart, that's your distance, at 6 p.m., find the rate of each bus. So what do we know about the time? The eastbound bus left at noon and traveled until 6 p.m. That's 6 hours. The westbound bus left 2 hours later, so he only traveled 4 hours. Now we can substitute these things into our master equation. RE is RW, TE is 6, plus RW times 4 equals 500. So I've got 6RW plus 4RW equals 500. So 10RW equals 500. Divide both sides by 10. and RW is equal to 50. Okay. Now, the rate of it said find the rate of each bus. If the rate of the westbound is 50 and it is equal to the rate of the eastbound, then the rate of the eastbound is also 50. Okay, one more. A train starts from Peoria at 2 p.m. It heads for Reedley, 750 kilometers away. There you go. That's where that goes. And heads for Peoria at 85 kilometers per hour. Now we have a rate, right? The second train. All right. If the trains meet at 5 p.m., what is the rate of the first train? So we know the rate of the second train is 85. We can figure out the time because they left, both of them left, see, at the same time. Both of them left at 2 p.m. and traveled until 5 p.m. So that is a total of 3 hours. They both traveled for 3 hours. Our master equation, RFTF plus RSTS equals 750. We're going to start substituting some things in. We're trying to find the rate of the first train. All right, so TF is 3. RS is 85. TS is 3. And we are trying to find RF. So we have 3RF plus 85 times 3, which is 255, equals 750. Subtract 255 from both sides. And we have 3RF is equal to, let's see, 14, that's 6, that's now 14, that's 10, that's 5, 14 minus 5 is 9, 6 minus 2 is 4. Divide both sides by 3. And 3 into 495, 1 minus 3, 1 9, that's 6, 1 8, that's 15, that's 5. So RF equals 165. So the rate of the first train then would have to be 165 miles or kilometers per hour. Sorry, kilometers per hour. Good job, and I will see you back next time for lesson 95. If you get mixed up in your problem set, remember that in this book, under each problem number, there is a smaller number in parentheses. It tells you what lesson that is from. So right now, while you're learning to set up these distance problems, if they are from lesson 92, they're going to be set up as the first distance equals the second distance. If they're from 94, they're going to be like this. Distance 1 plus distance 2 equals a number. Okay, so remember that when setting them up. And I'll see you next time.